Hi everyone, welcome to our talk and thanks for coming. Um, we're talking about Kubernetes CRD design for the long haul, where we want to try to share tips and tricks and stuff we learned in our journey with Cluster API and designing APIs. Before we start, we want to introduce ourselves. I'm Christian, I'm a maintainer in Cluster API and a software engineer at Broadcom.
Hello everyone, thank you for being here. I'm Fabrizio Pandini. I'm also a Cluster API maintainer, and I work in the same team of Christian in Broadcom. So, the long haul. So, let's start with a pool. How many of you are maintaining a project software, contributed to a project software, no matter if upstream or downstream, open source or not? Let's raise a hand, please. Okay, some good developer vibes in the room. So, you all probably know that every software project keeps evolving. As soon as users start using your project, you start getting feedback. You start getting requests for improvement. And so, also your API or your CRD have to improve. But your API, your CRD, is slightly different than your binary. You need a strategy to make sure that your CRD evolves nicely in the long run. In the Kubernetes ecosystem, let me say, the most common strategy to make your API to evolve is based by two complementary ideas. The first one is that you want to keep evolving your current API version. If you think about it, this is what they are doing in Kubernetes. Kubernetes is V1 since a couple of years now, and it keeps evolving. But sometimes, what you can do with a single API version is limited. So you cannot do breaking change. So sometimes you also want to create new API version. But the key point here is that you want to create API version only after a careful and deliberate decision. This is the key. So today's talk is about avoiding making mistakes that will force you to create unplanned version. Okay. Before talking about mistakes, let's have a quick refresher on how we develop APIs or CRD in Kubernetes. So the process started by writing a Go types. You write a Go types, then what you do, you run a generator from controller gen, and this generator creates a CRD, where the most important part of the CRD is the open API spec that reflects your types. Finally, you apply this CRD to the API server, and the user can interact with your API by writing YAML. So, if you look at this process, where do you think mistake could happen? So, on the right side, there are the users. Users, by default, are always right, so they cannot make these mistakes. In the middle, we have the generator. Generator just works well. So, what is left? Only Go types. So, but what could possibly go wrong when you keep a Go developer and you ask him to develop a Kubernetes API? Well, so with all the respect for my fellow maintainers and contributors, a lot of things could go wrong. So let's start looking at what mistake we could happen by going through some of the lessons learned in the last few years.
Yeah, so first we're going to dig into some Go examples where we could do mistakes. I'd like to show first three anti-patterns we identified. So the first one is embedding external APIs. In our case, Cluster API tries to create clusters, and we do that in a provider by, for example, using kubeadm. We want a user to also be able to configure things there, like he maybe wants to enable a specific flag for the kube API server, which is part somewhere there in kubeadm's configuration. A kubeADM binary itself is normally supposed to work for a single Kubernetes version. So if you take a look, for example, before v1.29 Kubernetes, kubeADM used the v1 beta 3 version of their cluster configuration. Starting with the version after, with v1.30, they started using a newer API version because they introduced some changes. In cluster API, though, a user wants to create clusters in different versions while running them in different versions. There could be clusters running 1.29, while still others are v1.29 and others are already at v1.30. So we can't just embed the v1 beta 3 or v1 beta 4 API version of kubeADM and expose that one to the users, because what if they want to create a cluster with the other version? So what could happen there is, or what's the mistake here? We just can't do this because it would be a breaking change if kubeADM itself evolves, introduces changes, we bump our Go dependency and have to use the newer v1 beta 4 version, but would not be able anymore to create the older versions then. So what we do instead is we copy, adapt, and evolve. We have our own copy of that configuration, our own struct we use and expose to our users, and in the backend we convert to the version we need when creating the cluster, because the user defined v1.29 or v1.30. And by that we can support a long range of Kubernetes versions like v1.27 to v1.33, while still using kubeADM's v1 beta 3 or v1 beta 4 in the backend. Another example of embedding external APIs would be in cluster API, we have this cluster object, and of course we need some control plane to run in our cluster or for our cluster. For that, we refer a control plane object in our cluster object. When modeling that, we decided to use an object from the Core v1 package. Core v1 seems to be stable. It should not evolve that much, so we shouldn't have issues when bumping to a new Go module version of Kubernetes. But what's the mistake here? We just started using Core v1 object reference, but and it worked. We're fine. We still have it like this today, but there are, for example, 3 fields in there which we don't need. Users see these fields in the API, they might expect something to happen if they set these fields, but they're actually unused. Just removing these fields is not that easy because it may be a breaking change if a user misused that field before, and we try to get rid of that when going to v1 beta 2, because we can't do it in our v1 beta 1 API. So what should we have done instead? We should have seen, okay, object reference is a cool example. We reuse that, but we create our own copy and only use that or have the fields in our API which we really need and skip adding the other ones. And in this way, if we later on maybe need a UID field, we just could add it and make use of it, but only when we need it. A third example, which is also pretty similar, but does not depend on external APIs, is in our machines, we have a spec, and a machine itself is supposed to be one unique item. We also have the concept of machine templates to create a fleet of machines. So at the first hand, we thought, it's totally good to maybe just use the same spec and same struct, because a machine template, we want to define everything in there and create hundreds of machines of it. But let's consider the use case of adding something like an IP address, because we want to do IP address management with our controllers. What's wrong here is we did not consider that IP address, adding it to the machine spec struct, it could also leak into the machine template. And from the machine template side, it just doesn't make sense, because every machine at the end should have a different IP and not the same. So what should we have done here instead is the same. Copy, adapt, and evolve in a separate struct type. We should think about, do we need to evolve these different objects separately, and because converting between one and the other struct is pretty simple, but just swapping out Go types may end up in completely different OpenAI API specs depending on what we do or if we do not do it carefully.
Okay, so after seeing 3 examples of bad things that can happen if you embed an API, you might ask yourself if it is always bad to reuse existing Go type. And the answer is no. In some cases, it's perfectly fine. In some cases, you have to. For instance, in your CRD, in the Go type for your CRD, you have to embed the type meta and object meta in order to make them proper compliant Kubernetes object. There are also other types that were explicitly designed for reuse, like condition, meta v1 condition in Kubernetes, or like type, or like time, which provide nice and then this serialization of timestamps. In some cases, it is also good to reuse your own types, but you have to carefully consider what are the implications in order to avoid the problem that Christian just described. Taking a step back for a minute, let's look again at how we develop the API. So this process, unfortunately, might lead or might trick maintainers, because as a maintainer, we focus a lot on writing Go types, and we just think, oh, controller gen will take care of everything and generate everything correct. But this could be misleading, because at the end, what impacts the user is the OpenAPI spec. So, pro tip or lesson learned here is that whenever you change your Go type, run the generator and look at the OpenAPI spec. So it's not too difficult to read, and you really can figure it out what impact will your change create to the users. As a last tip of this first session of the talk, let's talk about a minute about rules. So when we talk about API guarantee or API breaking change or API deprecation rule, they apply on the OpenAPI spec. Okay, this is what impact user, this is where guarantee apply. If I have one beta, one API, and when I'm going to deprecate it, it will take 1 year or 3 releases. However, from the other side of the equation, some other rule apply or some other policy. This is a Go binary. This is a binary. This is Go will combine into a binary, so semver apply. What are the implications of these 2 rules applied to the same artifact? Is that if you are in a bad corner and you know your audience, which is super important, you might find very pragmatic way to solve an issue. Let's make an example. You want to rename a Go type. You could do it. If you, for instance, if your API package is used only by someone internally of your company. It's a breaking change, but you can manage it. Okay, and this way might help to solve some of the issue that Christian described.
So we talked a lot about Go code. What about comments? It can't be too hard. There should be no issues there, right? Let's make an example. For generating CRDs, we often use these magic markers, which are, for example, used by controller gen to influence the OpenAPI spec. What could we do wrong here is we could simply miss setting the right markers, like the max length validation is very important, for example, for cell. Cell is all around us, and validating admission policies only work if you use the proper, if you add the proper validations which result to the right fields to be set in our OpenAPI spec. Another example is setting fields you consider optional actually as optional, which also might influence how it results in the Open API spec. So what we could do about this is, there's a solution for this. There's a project called CAL, which is short for Kubernetes API linter, which checks for common practices and enforces best practices in your code. It's a super good linter which integrates nicely with Golang CR lint. And at this point, I want to give a shout out to Joel, who has started this project and is driving it, and to everyone else who is contributing to it. The project itself is planned to get a home in SIG API machinery as repository. And yeah, please, it's a good thing to start using it, and it makes you help think about some decisions. Maybe not every linter rule applies for your API in that field, maybe, but then you can do explicit exception of that and note that in your API or in your GoDocs as addition. So one more example where Cal could help you in future is the following. We have a cluster object, which, for example, has a variables list or array in it. We have a second controller also trying to add a field to this list or to this array. Per default, this list is treated as atomic, so both sides, the controller or the GitOps tool trying to sync the source to the target object, would always try to just set the instance type and the zone fields here, while our other tool like controller, which wants to just set a cost center field variable, adding to that field, just fights with our GitOps tool, and then we end up in infinite reconciliations, which costs performance, costs resources, and it's just not good. The solution here is setting the list type and list map key markers. So OpenAPI understands this array not as array, but as list map, which then helps to have co-ownership of entries inside this list. That's the linter which is planned to be implemented in Cal. It's not there yet. There's a couple of more and open wishes for it. So yeah.
Okay. So at this point, you might think that you now master writing Go types for Kubernetes API. You know about types, you know about comment and magic markers. Unfortunately, this is not enough. So there is one last category of mistake that we can do as a developer when writing an API. And this is the most common and the most tricky to get right. And it is about the mistake in field names. So let's think about an API. An API is a representation of what your project is doing. Every project is solving a unique problem. If you think about cluster API, this is a short project statement for cluster API. If you think about the corresponding cluster object, you can imagine it as a different representation of the same statement. It is what you present to your user, is what tell user what your project is doing. But what is the biggest difference between the two forms of project statement is that on the left, you have a context. You have full text sentences that explain what your project is doing. On the right, instead, you have only a few keywords. And the key point here is that in API design, every one of these keywords matters. So it is really important to choose the right keyword. And what are the common mistakes here? There are a lot. So if you not choose accurately the keywords, your API might be confusing for your user. If you use synonymous or abbreviation for the same word in two different CRD of your project, your user may be confused as well. If you use generic term, lightly without thinking carefully at it, your user might be confused. What does this mean? Okay. And making user confused is not the only issue. The real problem is that when you choose the wrong keyword, then changing a keyword, renaming a field in your API is a breaking change. So what is the solution here? Luckily, there are a few tips that can help you. And one is really simple and effective. So you can try to do this exercise. You can try to read your API and transform it and build a sentence that starts with I want to. I want to because it is a declarative API. So if you do the exercise here, is that I want a cluster with a topology that has a control plane with 3 replicas. It is a simple sentence. It makes sense. It is easy to read. User can understand it. This is a good sign, a good evidence that you are creating a good API. If instead your sentence doesn't read well, it is not proper English, or the words are not good, etc. This is a first red alarm that you are not building a nice API or something that you will regret in the future. The second tip requires a little bit of more of work, but it is really, really effective in the long run. So if you think about it, every project has a glossary, has a set of terms that are specific of this project. Unfortunately, not every project writes down its glossary. Okay, so what are the benefits of having a glossary? There are many of them. First of all, a glossary will help users in reading your API, will help users when they look at your documentation, will be a good companion for your user. But it will be even more important for you maintainers and for the maintainers that will follow you. Because if there is a glossary which defines terms, which give a context, which allows everyone to understand the keywords in your API, this will help when you will add something on top. We try to extend your API. You will create a new CRD in your API. So the benefit of having a CRD are very worth the effort, and on top of it, you can also consider that it's something that you can build over time. So it's not something that you have to do upfront as a huge effort.
Let's have an example what we, in that case, for example, did wrong. We have the concept of infrastructure providers, which have, for example, an AWS machine for AWS. We added a field in our contract to say, okay, AWS machine should notify that in its status with a ready field that it's ready. But what does ready mean? Is the node ready? Is it up and running? Is it provisioned? If you had come from the glossary or from a definition of what we want to have out of that field, it would have been each infrastructure machine must report when a machine's initialization is completed and infrastructure is fully provisioned. That's what we actually present with the old status ready field. It's something we're going to try to fix with the V1 Beta 2 API 2 in our contract there. And the mistake here is simple, just lightly using that wrong wording, and which then results in an inaccurate and not explicit API, which could be easily misunderstood. Another example on that, camel casing. Let's think about having an API which does the same as kubectl drain. We start with having a flag, or kubectl has a flag for grace period. So we start adding a field called node drain grace period. At the next version, we think, grace period is not enough. We also need a field for the timeout flag. So we add node drain timeout. We're consistently extending our API we did before, but it reads a bit weird. What we should have done instead is think about embedding in extensibility. If we would have added a node drain field which contains the grace period, we could easily expand and evolve with adding a timeout field or others later. So consider using nesting to be extensible. There are other examples where cal, for example, helps you, like think about not using a Boolean, but maybe use a enum instead, because you maybe want to have different meanings later on. And last pro tip for today is get inspiration from the best. API design is not a one-man show, and consider getting feedback where you can, like peer reviews, ask users, take a look at other Kubernetes projects or Kubernetes API types itself, but critically think of if the same applies to your API and if you should do it this way or just adapt some parts of it. You could even ask an AI, but consider thinking about it again.
Okay, so before wrapping up, let's quickly talk about what we did not cover in today's presentation. So we did not have a deep dive on CRD markers. There are many of them. Some of them are simple and intuitive, like min-len, max-len, most of the one about validation. But there are really many of them. So there is a good documentation, the link is there, but again, the trick is apply a marker, generate your CRD, look at what they looks like in the OpenAPI spec, and test it in the API server. It's simple and very effective. What else we did not talk about? We did not talk about creating a new API and deprecating and removing the old API version. Well, this is way more complicated than it should be, because unfortunately there are problems that you have to take care of, like storage version migration, and also you have to deal with a few annoying API server issues that we are also trying to fix in parallel. Maybe this will be the topic for the next talk. We also did not talk about some other trick about API development, like how to make your API to work well with backup and restore tool like Velero, for instance. And wrapping it up, so API design is a journey. Enjoy it, share your learning, and have fun. And with this, thank you for attending. We will get your question if you have to.